Here's a quick science problem for you. Imagine that you're driving at night. It's really dark, so you turn on the headlights. How fast is the light going from that headlight? Is it A, the speed of light, or B, the speed of light plus the speed of the car? If you said A, the speed of light, congratulations! You either understand Einstein's theory of relativity or you're just lucky. But if you said B, that's okay because we're here to tell you why you're wrong. Right now.
We choose to go to the moon.
The rum-tum tugger is a curious cat.
100 billion other galaxies.
Right now, you like me.
Welcome to 5 Minute Trivia, where we're making the world smarter 5 minutes at a time. I'm your host, R.M. Zubairi. In the year 1905, a clerk in the Swiss Patent Office of all places published a paper called On the Electrodynamics of Moving Bodies. It had some math, but nothing that your average high schooler couldn't handle. It was based on just two simple ideas. And yet, the guy who wrote it has been hailed as one of the greatest scientific geniuses of all time. His name was Albert Einstein, and this paper presented the special theory of relativity. His theory of relativity actually has two parts, special relativity and general relativity, but special relativity is the one that explains how stars and black holes and nuclear fusion work. It gives us sci-fi stuff like time dilation. It also gave us E equals mc squared, possibly the most famous math equation in history. Einstein came up with his ideas through a series of thought experiments and one absolute rule. The rule is that the speed of light in a vacuum is always the same, 300 million meters per second or 186,000 miles per second, no matter what it's attached to. That is the speed limit of the universe. Only light can travel that fast, and it always travels exactly that fast. So this doesn't match anything else we know. Like if you're inside a car and you throw a ball, the speed of the ball is the speed of the car plus the speed of the ball, right? But light doesn't work that way, which leads to some pretty wild things. Like in our car headlight example, the speed of light from a stationary flashlight and the speed of light from that headlight attached to a moving car is exactly the same. The only way that works mathematically is that time has to slow down as you get closer to the speed of light. Time is distance divided by velocity. So if the velocity is going up and the distance is the same, time has to go down. It slows down for the people in the car. This is called time dilation. What it means is that time passes differently depending on how fast you're going. The closer you get to the speed of light, the slower time goes for you, and you don't age as fast as everyone else. Sounds like science fiction, right? Nope. This is science fiction.
Oh crap! Prepare to jump into hyperspace on my mark.
All right, stand by.
In real science, whenever anyone in Star Wars jumps to light speed, they will come out of it and find that everything around them is older. They don't need to fight the Empire, they just need to jump to light speed and come out when Vader and the Emperor have died of old age. This has actually been proven in experiments using super precise clocks. In fact, GPS satellites in orbit around Earth are moving so fast that they experience time dilation. Their internal clocks have to be programmed to account for these effects. Otherwise, they end up out of sync with the clocks on Earth. Now, we come to E equals mc squared, probably the most famous equation in all of science. Everyone knows it, but what does it mean? So E is energy, m is mass, and c is the speed of light. So the equation says that energy equals mass times the speed of light squared. This equation is why the speed of light is the speed limit of the universe. The closer you get, the amount of energy to get a mass up to it goes up exponentially. But it also explains stars, black holes, and nuclear fusion because it shows that mass and energy are equivalent. In our episode on stars and black holes, we covered how stars release energy and become more massive as they're collapsing. This phenomenon is perfectly predicted by E = mc squared. If you haven't listened to those episodes, we encourage you to do so, because if we had to do it all over again right now, we'd need some time dilation ourselves. In a future episode, we'll take on general relativity and the idea of space-time. That's it for this week's show. Join us next time, and thanks for listening.